Hi, today I have for you a short video about connection in IDEA Statica, which should connect two crossing IPE members with 4 diagonals. And I got this model or question today on the hotline. The customer asked how to connect the diagonals to this crossing members, and I think this could be interesting for more people, and I got also the permission from the customer to show it to you. My name is Ivan Beleš, and I am responsible for support of SciEngineer and IDEA Statica in Austria and Slovenia and some countries. Now we are directly in IDEA Statica. This is the finished model, only to show you how it will looks like on the end. So we start connection, and we start one empty connection. Will take a little bit time. It's my old computer and probably the last video recorded on this old 7 or 8 years old computer. Next week I should get a new one. So I create some new empty project. Usually I start with empty project during trainings that the people see from scratch how is it inputted. So we need two crossing members. Each EA 300 is my favorite cross section. So right mouse button on the member, new member, and we will use this HEA 300. Okay, this member should go through the connection. Therefore, it's not ended, it's continuous. And usually in the last versions, the equiload equilibrium is activated. That means that if you have a continue member which is supported, one member is supported, then you get support only on one side. So in this case, I don't need to design this member. Therefore, I will deactivate it, so I don't have to care about the equilibrium of the internal forces, and this member is fully supported on both ends. So, and now the second member, new member. So you can rename it. Yes, you can rename the members. I leave it so. So the second member will be rotated around 90 degrees. It's also continuous, but it's in wrong position. So I have to lift it to this top flange. So the bottom flange of this member should sit on the top flange of this member M1. So how you can do it? You can align. You can align one member on the top or bottom of another member or on some part. So what we have to do, we say align plate, this is my member M2, and the bottom flange of my member should sit on the top flange of M1. And then you can define the top and bottom surface. So the bottom surface of the upper beam should sit on the top surface on the lower beam or bottom beam. So that's correct. Now we need these 4 diagonals. Right mouse button, new member. I will rename them D1, diagonal 1. This is another cross section. This is this simple 20 mm rod. And I will rotate it 45 degrees. This is not continuous, this is ended. So go to the transparent to see where is it. Maybe view from the top. Don't care about the position, top and bottom. This will be changed automatically in our connection. Some of the connection components, like gusset plate or this connection plate, can also move the diagonals, because the diagonals are in the finite element analysis, maybe mainly in the axis. So, but you need it sometime on the flange or somewhere. So then we can copy it, rename to D2, and again copy D3, and next copy D4 to have all 4s. So So, and this is 45, 135. This will be minus 45, and this will be minus 135. So it's very simple. These diagonals will be connected only with one bolt. That means if we have the diagonal around one bolt, then this diagonal could rotate. So if we have two bolts, then it's fixed, but with one bolt, it's a rotating system or kinematic system. Therefore, Idea Statica needs to add some supports. So you can do it with this member type. And if you say this is a truss beam, only axial force and shear forces, then you see Idea Statica will add some supports on the end so that the end is each time vertical and it can only move to the top or bottom and can go in this direction, but it cannot rotate. So, and we will do it for all members. And this is everything what we need to change at our members. So they are in the right position. I go to the solid view and we can start with the connection. So no, we need some loads. I have some paper, 30 kilonewton for the axial force, then the shear force on this boat, on this one top beam on the purlin, minus 10, yes, and minus 10, and bending moment also 10, no, minus 10 and 10. Okay, now we can start with the operation. Right mouse button, new operation. We will use this operation today and the bolts, these two operations. So connecting plate. For these rods, you can use two, I will delete it, my mistake. New operation, you can use these two operations to connect the rods. Rods are only the only one 1D member. All members are collected from plates, but the rod is 1D member, so therefore there is a limited possibility how to connect them. So we need welds on the sides, and there are predefined these two operations which can be used. So what we want to connect? We want to connect D1. And what is our goal? It was I should explain on the start. Usually with this connection plate, you create some plate, and onto this plate will be added this second plate. But the customer wanted to connect everything with one bolt. So this one bolt should go through my connection plate, through the bottom flange and top flange of both members. So, and this is the explanation how to do it. So, we don't want to use a new plate. We want to connect to a member plate. We will connect to this bottom flange. So where we are, what we are doing, what we are connecting. D1. What is D1? Go to transparent. What's this? This is the D3. This is the D1. Okay, this is my connection. Okay. So D1 to member plate. To which member? To our top member. This is M2, and to bottom flange of this member. Okay. But we don't connect with some cup plate. We need this notched plate, walls or rectangle. I have used rectangle. It's not very nice. This is a very long distance, so I will change it to 130 millimeters. Then it's inside. So, and then it's sitting on the correct position. It should be 10 millimeter, or let's say 20 millimeter the thickness. Okay, so to have the same thickness like my rod. But okay, change first the dimensions. 70 and the thickness. Where is the thickness of this, the width? This is the plate width. Okay, that's everything. That's too much. I go to 16 millimeters. Okay, I should use also 16 millimeter. I will not change it. Or okay, let's change it, because I need to change it only one time. I can go to 16 millimeters, because if you change it, then it's changed for all cross sections. Okay, now it's correct. And you see, this is a little bit in this top flange. That means this is not correct. This bolt connects only my plate and this bottom flange, but I need to that it goes through all three plates. So very easy small trick which you can use in each connection. If you don't like some component of your connection, mainly welds and bolts, simply deactivate it. Not change it to 0, simply delete the row, and then the bolts disappear and you can create a new bolt. So it's very simple. So we can change this the geometry to have some arc on the end. I go to the tank and add some arc on the line 2 in the opposite direction. Okay, now it's correct. And now I need the bolts. Right mouse button, new operation. This is the second operation today. These bolts, and this bolt connects. Oh, okay. This bolt should connect my plate. This is the CPL1, and should connect 3 elements. CPL1 and then 2 beams. From M2, the bottom flange, M2 bottom flange, and from M1, the top flange. Okay, and if you look at it, then it's correctly the position. So we only have to change the placement of my bolt and everything is done. I have to go back. You see these welds are on the wrong side, so you can do it on this side or on both sides, depending on your geometry. Was not my idea, this connection, but I think could be a common connection, maybe, don't know. Okay, now we have only to copy it. Create a copy, connect D2, this will be also created a copy, and we change it to CPL2. So nothing special, it's done automatically. I'm struggling each time with this rotation. I am too old for it. So right mouse button, copy, connect D3. Right mouse button, copy, connect CPL3. And again, CPL3 will be created to CPL4. We connect D4 and the grid copy with CPL4. Everything is done. So it was very quick. We have to calculate it, check the results. It will take a few minutes. Hopefully everything correctly inputted. Okay, bolts. Oh, what is with the bolts? Grid. What? M16. Oh, it's 4.8. Okay, I didn't check the bolts. 8.8 M16. Okay, and this one. Also, the last one. Also. And the same. No, it should be correct. Okay, the utilization is okay. We can go to the check, look at the stresses, for example. Then you see the stresses. You can look at the plates, you can go to the plates. Where is it? Equivalent stress. Stick strain, equivalent strain. What I don't see. Aha, okay. I work on the biggest screen, so now for the videos I reduce the resolution. So okay, so you can check everything and make then a report and put it out. So I will not do it. Okay, one change to all my previous videos. If you want to have the model, below the video there is a description in YouTube. There is also a link. If you click on this link, you will be related to a landing page. If you write your email address and name, immediately you will get an email with a link to the model. Maybe you get 2 emails because of this GDPR law in Europe, so it's complicated, and but you have only to write your email address and then then confirm that it's your email, and then you get this email. And if you want later, you can unsubscribe from this, because it goes to a newsletter. You can unsubscribe. So I will try to give you also the model. Hope it was interesting for you, and maybe you will watch another video from me. Thank you very much, and bye.